Hey everyone, and welcome. Today, we are going to pull back the curtain on a really important concept in Java, the constructor chain of command. Now, you might be thinking, okay, why does this matter so much? Well, let me tell you. If you want to write clean, bug-free code, and especially if you're prepping for exams or a technical interview, you absolutely have to understand how constructors work during inheritance. By the end of this, you'll be able to trace the whole process like a pro. All right, here's our game plan. We're going to start with the secret first job of every constructor. Then we'll get into the super keyword. That's the link to the parent. We'll see how to take control with parameters, check out its sibling, this one, and finally we'll talk about the granddaddy of all classes, the object class. Let's do this. So let's kick things off with the number one most fundamental rule that governs every single constructor in Java. It's a rule that pretty much works its magic behind the scenes. So let me ask you, what do you think a constructor's real first job is? You know, the very first thing it does? A lot of people might say, oh, it's initializing variables, but that's actually not it. Before any of that happens, there is one mandatory task that has to be completed.
And that first job is to kick off the constructor chain. Just think about like building blocks. Before you can put a block on top, you need to have a block underneath it, right? It's the same idea in Java. A subclass constructor must call its parent's constructor first, ensuring the object gets built properly from the ground up.
So how is this chain actually formed? Well, the key to this whole operation is a special keyword, one that's often invisible because the compiler adds it in for us. And that keyword is super, colon. Let's look at a really simple setup. We've got a parent class, we'll call it A, and a child class, B, which extends A. Now, if we go ahead and create a new object of B, what do you think is going to happen? What's the output going to be? And surprise! You might expect to only see in B, but look at that. We get in A first, then in B. So even though we only asked for a B object, the constructor for A ran first. This isn't a bug. This is exactly how Java is designed to work. And the reason for this little bit of magic is the super keyword. The best way to think about it is like a mandatory phone call to your parent. Before a subclass constructor can do any of its own work, it has to call super to run its parent's constructor first. This is what's really happening under the hood. Even if you don't type it, the compiler secretly injects that super call right there as the very first line. It's an automatic safety feature to make sure the parent is always set up before the child. Now, that default no parameter super call is great, but what happens if our parent's constructor actually needs some information? What if it needs parameters? Well, this is where we have to step in and take manual control of the chain. And this slide lays it out perfectly. On the left, if we do nothing, the compiler tries to call the default parent constructor, one with no arguments. But on the right, we explicitly write super n. We're telling Java, hey, don't use the default one. I want you to call the parent constructor that takes an integer. It's the difference between getting a plain pizza and specifically asking for one with toppings. Okay, let's trace the flow here. It's super important. First, we call new B5. That kicks off the B constructor. Its very first instruction is super 5. So control immediately jumps up to the A constructor. A does its thing, prints its message, and then control comes back down to the B constructor to finish its job. The flow is always up and then back down. Okay, so we've seen how to call up to a parent with super function. But what if you want to call another constructor in the very same class? You know, to avoid writing the same initialization code over and over. Think of it like delegating work to a coworker on your own team. And for that, Java gives us the this keyword. It's a way for one constructor to call a sibling constructor in the same class. This is fantastic for reducing code duplication. You could have, say, a simple constructor that just calls a more complex one with some default values. Really handy. This table right here is your cheat sheet. Seriously. Super calls up to the parent. This calls sideways to a sibling. But here's the golden rule, the one you absolutely have to remember. Either one of them must be the very first line in a constructor. You can have super gearing or you can have this gearing, but you can never, ever have both. Okay, time for a little puzzle. If every constructor has to call super, what about a class that doesn't extend anything? You know, a class at the very top of its own hierarchy. Where does its super call go? The answer is the mighty object class. You see, in Java, every single class is a descendant of object. Even if you don't write extends object, the compiler puts it there for you. It is the ultimate ancestor of every class in the entire Java universe. And that's the final piece of the puzzle.
The object class acts as the anchor for the entire constructor chain. When your top-level class makes that supercall, it's actually calling the constructor of object. This guarantees the chain always has a definite endpoint. All right, let's pull all of this together into a few key takeaways. If you're studying for a test or getting ready for an interview, this is the part you'll want to commit to memory. These are the 5 unbreakable laws of constructor chaining. 1. The first line is always this or super. 2. If you write nothing, the compiler adds super for you. 3. Super calls up to the parent. 4. This calls across to a sibling. And 5. The whole chain reaction always stops at the object class. Master these, and you've mastered the concept. So when you really think about it, this whole process is about building a solid foundation. It ensures every object is constructed layer by layer, starting from its most general blueprint, the object class, all the way down to its most specific, detailed form. And that's a wrap on our explainer. Now that you know the rules of the game, I've got a challenge for you. Go find some code with a few levels of inheritance and see if you can trace the constructor chain all the way through. Can you predict the exact output every single time? Thanks for watching and happy coding!